Neeraj ji, my voice is audible?
Yes, audible, sir.
Okay, okay. Good morning to all the participants and our today's faculty, Sri Prashant Joshi sir. I welcome all of you in this online training program on modern topographic surveying methods. This training program is started today and it will be completed on 18th of October. So this training program has been designed for 7 days, 5 days in this week and rest 2 days in the next week. Saturday and Sunday will be the holiday with respect to this online training program. In this training program, we have received 138 nominations from 13 organizations, including NHI, Ministry of Road Transport and Highways, NHIDCL, and various public work department, as well as the PMJSY divisions. The NHIDCL has also various divisions in all over India. 14 divisions of the NHIDCL has nominated their officers for attending this online mode of the training program. Generally, this training program that is on modern surveying method is basically is a two-way combination of theoretical as well as hands-on training. But during these 7 days training program, we mainly focus on the theoretical part of this training program. In that, we will cover the provisions in TOR of DPR, consultant for topographic surveying, desktop study of alignment using topo sheets and Google Earth. We will also discuss about the differential global positioning system DGPS, auto label surveying, total station, lidar, aerial photogrammetry using drone. But uh, whenever we conduct this training program as a calendar training program in our campus, this training program is being conducted for 5 days, forenoon and afternoon. In that, we also impart the hands-on training and practical experience to all the participants also. However, we are thinking that from next financial year onward, we will conduct this training program in our campus so that participant can also get the benefit of the hands-on training and the practical example of understanding the surveying equipment such as total station, lidar, drone, DGPS or auto label surveying. I also expect from the participant that they will interact with our faculty, sir, and they also make it a interactive session. They will ask the questions whenever they feel the difficulty during the presentation or understanding the subject. In this training program also, we will also issue the certificate to the participant, but we will issue certificate to those participants who will secure minimum 75 attendance for all 7 days training program. In all days, there will also be a 15 time break at around 11:15 to 11:30. In that, participants are not required to leave the meeting, but they can take rest or take and do their other works during that time. So our faculty will take also rest for some time. I will not make much more time. I request Sri Prashant Joshi sir to start his presentation as well as his experience with the participants so that the participant can understand the thing in a better way. Thank you.
Thank you, Gupta ji. As I understand, most of the participants are from the client organization. So what I would provide is actually my subject is I'll share my screen also, and then I'll. So And I request participant to interrupt with me anytime in between my presentation and then discuss, share their experiences. I'm a consultant and I have done number of DPR. So as a part of this terms of reference, what I will be discussing is the DPR in overall and then terms of reference for topographical survey, and then what are the types of topographical survey. We start from theodolite. I think most of us are engineers, so must have done the topography, started topographical survey, learned the basics of topographical survey. This is theodolite survey, a plane table survey, which, and then we are graduated then to now modern lidar and GPS systems, photogrammetry. So why we are then what are the different pros and cons of different type of survey, and then if you have got to define a terms of reference for, because this is the terms of reference what you will be giving it for the consultant. You will get the normally detailed project report is done by a consultant. It will be outsourcing it to the consultant, and then so this my presentation would help you to define the means the terms of reference, and then I'll be making reference of the Ministry of Road Transport as terms of reference. So, and then these terms of reference is issued by Ministry of Road Transport for all centrally sponsored, centrally funded projects. So, but this can be modified for a specific purpose, because these terms of reference is mainly for a highway projects, national highway projects, and then but for a small type of road, for a single bridge or for a tunnel or this modification can be done. So we'll be discussing those aspects also. So I request participant to be interactive, ask any question, share their experiences. Most of the participants, many of who already may have experience in this kind of survey. If you had faced a difficulty, and I will also share my experiences. Okay. So I will start with this. So there is detailed project report. So what is the detailed project report? Okay, so why do we do the detailed project report? The detailed project report, it is required to establish technical, economic, and financial viability of the project. Suppose you want to means the how the projects conceptualize. The project is conceptualized based on the public needs. Why? Because a road is a public infrastructure. We provide this is provided transport. This satisfy the transportation needs of the people. So whenever a need for people, it comes from the requirement of the public. As a human being, we have to transport our products and resources. People have to meet each other, travel in different. So, and then by road transportation. So for the road DPR, if any transportation connection is needed, so whether this connection is technically feasible, though the DPR project is the ultimate first thing is will be the conceptual, some the people need, and then DPR establish the technical viability, economical viability, and financial viability. Why technical means whether technically it is possible to construct a road. Economical, whether any infrastructure project has to be economical and financially viable. So economically means the economical and financial two terms. One is economical is from government's part. Government wants to enhance the economy, means for betterment of the local area, like backward areas where the economy of those backward areas is to be improved, so that the economic viability has to be established. And then financially viability is whether the project is financially viable, whether the investment, because these infrastructure or road project requires huge investment, crores of rupees, thousands of crores of rupees. Like we are constructing from village roads to expressways. So the kind of road it is required, and then whether the it is financially viable, so that somebody can invest and get the returns. If the returns, whether returns or returns justify the investment. And then, so this is the output of planning and design phase. And it is the most important phase. You can see my last line, the most important and crucial task for hyper detailed project. Because this is a part of planning and design. If something goes wrong during implementation, it gets to a lot of cost overruns, time and time delay. And time delay turns into the cost delay. So if any inaccuracy in DPI, the repercussions are very serious. And then what is the now as a part of technical life? So what are the for this carrying out this detailed project report? We do number of surveys and investigation. So these are the alignment surveys and investigation, cost estimation, economic and financial viability, and preparation of tender document. This is complete part of detailed project report. So alignments, surveys and investigation. The alignment survey, that is part of topographical survey. Then there are geotechnical investigation, hydrological investigation. There are number of investigation. And part of DPR also includes the statutory clearances, land acquisition. When you want to construct a road, either there are two types of project. Either a widening project, means a rehabilitation and widening project, or a greenfield alignment project. In both the cases, you need to acquire land, public land or private land. So this is also established from the DPR, and DPR actually topographical survey is most important part of the DPR. So the DPR will establish the final blueprint of the project, after which implementation and operation process can occur. It means once the detailed project is ready, then because the tender documents are a part of detailed project, then as a client organization invites tender for the contractors or concessionaires to build the project, and then accordingly the project execution starts. So it is the initiation. The detailed project is the detailed planning and design process. Correct. So if we start with the, there are part of the survey, the reconnaissance survey. Hope everybody knows reconnaissance survey. Can anybody tell me what is reconnaissance survey? Already opened the slide. So reconnaissance survey is the first hand established for means going to the site, visiting the site, and working out the means based on visual observation and based on the study of maps. Okay, can I ask people how many people have already been involved in the detailed project report? Means anybody, whether everybody has experience, so then accordingly my presentation, I will outline my presentation. Everybody has experience in topographical survey? Hello? Please be interactive. So, can you tell anybody has done the reconnaissance survey as a part of any road project we were involved in?
Yes, sir. I did.
So now what are the tools available? Presently we have the following on the desktop. We studying at an office. First, to start with the conceptualization, first we start with the desktop study. So what we do is we study of topographical maps. From where you get topographical maps?
Survey of India.
Survey of India. And what is scale? It is 1:50,000 scale survey of India maps are available. Then now we have got Google Maps. Earlier we used to get satellite imagery from Hyderabad, NRSA. So these are the desktop study or collecting the secondary information. In the desktop study, what you do is we get Survey of India map. Survey of India map provide us the initial part of the planning process, and then and ROW data from revenue records. So the process of ROW, actually ROW data, collection of ROW data gets a little time. So then you have to, for planning process, you have to prepare the alignment and transfer it. Data from the respective department. Then seismological, geological map, because this is a high. You have to take care of very natural calamity, particularly in hilly terrain. And then you have to work out the alignment alternatives, which are the obligatory points from where the road has to pass, and then which is the best alignment. So for alignment, you have to carry out the economical and viability. And then once the desktop study is completed, then we go for the detailed ground reconnaissance. So best I'll go to keep in mind. I'll go forward and back to the slides. So this is this is a project alignment where this is the topographical survey map which is procured from Survey of India. So these types of maps for entire country is available. You procure this map because for clearances also you need, for forest clearances you have to provide alignment on these maps. So we draw alignment first, tentative alignment on this. This is a desktop study. Then again, this is an expressive alignment which we did as a part of national highway study. So these are available on different. You can see this number from Survey of India. Whichever area you want to have you want to construct your road, or you are planning to do a road, you have to, from Survey of India, the entire country map is divided into different grids, and from grids, from the respective number, you have to procure those topographical survey maps, and then we join. This you see, there are about 1, 2, 3, 4, 5, 6, about 8 maps, 10 maps are joined together, and for this an expressway alignment. So this is the alignment we have planned as a part of a study. And then we establish changes. And here are the coordinates also. So now, because we have got to, we'll discuss when we go to further. So after first we procure this, draw an alignment, a simple alignment. This is because after constructing, the detailed informations are plotted on these maps, but otherwise we just on this, we just draw lines and then go for next stage. Next stage is verification of desktop study information. So for verification, because from the Survey of India maps, you can see, if you zoom it, there are rivers, then the topography is. So you can measurement of topography and what are the topo features there, how many bridges are required. So and ground survey, whether it will be possible. So this is the desktop you can now, because we already have a Google available on your desktop. From internet, you can just see whether this alignment, and then updated information is available here. But this is not a scaled map, so but you can zoom it and then you can find out from the latest information which is available on Google Earth, so that whether the project is viable. So here, you can do 2, 3, 4 alignment, 2, 3, 4 different alternatives, and then you can ultimately focus on one which is the best alignment. How you do it? Because detailed project, as a part of DPR project, there is also a feasibility study. In the first slide I already shown that this financially economical viability, how many bridges are required, whether you can cross it, or whether you can the alignment is feasible. So ultimately, first from this you can get a first-hand information. Then you go for this detailed ground spec. Somebody has to go on the ground. So that this is a topographical survey agency or topo who is in charge of the survey engineer who goes to the site first. And then the information available from the desktop you verify and update because some of the information may not be on the map. Then find out the obligatory point to explore the site condition, alternative routes. And further researches are taken up on the basis of information derived from the reconnaissance survey. I'll just open the terms of reference also just for your reference here. This is the terms of reference. Okay, has everybody seen this? This is the latest terms of reference, model term to DPR document, request for proposal document, and the terms of reference of the DPR is a part of this request for proposal document. The latest available, it is available on the internet. Yes, please. We'll directly go to the terms of reference. So these are the standard terms of reference provided by Ministry of Transport, and this can be modified. And it is already there. The agency may suitably modify the terms of reference with respect to standalone bridge and internal project. So a draft a document, a model document is already available.
Stone crusher / hot wet mix plant and QD
Yeah. Are you talking to me? Anybody? Mr.
Costume que já tinha para.
Hello, can you mute your mic? Hello.
Nie angażuję w zasadzie, ale.
I think Mr. Future, your mic is on. If you have any query, you can ask me. We unmute and ask me, but I don't disturb. Yes. So this is the object because my presentation is derived from this document. Okay, so this says that the viability of the project shall be established by taking into account the requirements with regard to rehabilitation, upgradation, and improvement based on the highway design, pavement design, provision of service road, wherever necessary, types of rehabilitation, and why. This is all what is involved in a highway project. Hello, please kindly unmute. Just kindly mute. Sorry, so mute your mic so that others are not disturbed.
Reference sheet क्या पास? इंडा जाता हूँ तो ना रोड में तो रोड नहीं थी मनो रोड there is no need just
Hello.
irrigation
Neeraj? Kindly request one of the participants to mute his mic.
this thing is incorrect.
So we talked about what is the scope of the topographic survey agency. So in terms of reference, you have to define the scope. So in the scope, normally the ROW for different kind of project is this is the anybody hello.
Están aquí lentos.
I request the participant to please mute it only when if you have any query or question on presentation or any something to share with the presentation, then only please unmute and discuss with me.
सारे देश
Right of way, and so the right of way now for national highways are indicated here. The expressway is 90 meter, economic corridor or for 8 lane it is 70 meter, national highway up to 6 lane 60 meter, national highway with plant capacity 445 meter.
लॉगिन कर लिए तो आई गेस वही अटेंडेंस होगा जी
Hello.
मैं मैंने
आपस में बातें कर रही है.
फॉर्मेट ये भी है पूरा
लिया टेबल तो वहां से उठा के ले आओ और हाथ में लिए बैठे हुए तुम्हारे सब
जैसा कंटिन्यू
Yes, please. So, in terms of reference of Ministry of Road Transport and Highways. Okay, so this defines the scope of work of the topographical survey for the DPR, and then we just go focus into the topographical survey related things. So, in case of upgradation of existing 2-lane highway to 4 to 6, 8 lane, or even for any road for that matter, the comparative cost benefit shall be necessary to be carried out while recommending the development of existing route alignment, and then alternative option to be established. So, what role the topographical survey played? Okay, so now I go into particularly the topographical survey area. So, reconnaissance is the first part of the topographical survey area. And then here, this clearly shows that, the consultant should make an in-depth study of available ROW. So within the ROW, for if it is an expressway, within 90 meter ROW, for it is a highway, it is 60 meter ROW, what are the topographical, we study the topographical maps, satellite imagery, Google, and then for land, what are the structures to be acquired, what are the utility services established, so are available or which are required to be shifted. So for this, you have to carry out the detailed ground survey. Okay, the detailed ground survey may be taken then after the desktop study. After desktop study, because detailed ground survey can be done only for one alignment. So on the desktop or Google study, you work out the alternatives, 2-3 alternatives, and then come to conclusion of a single best viable alignment. And then just for that viable alignment, you do the ground survey. So what are the different tools available for this survey? So topographics. So in the survey, there are different types of method tools available and the equipments which we use it. So topographical survey in TOR provision, you have to carry out with mobile terrestrial LiDAR survey. Aerial, the LiDAR is the light detection, and anybody has used the LiDAR survey?
No, sir.
Yes, please. Anybody? And why do everybody knows the topographical survey, isn't it? Topographical survey is the finding out the topography based on the ground survey. Okay, in the colleges you must have carried out survey, if not in the either in the field also as a part of your profession, or during engineering colleges, which is theodolite, plant table, or auto level survey. Earlier we used to do, and then we graduated into total station, from total station to GPS based survey, and then GPS is now LiDAR based. So why this modern LiDAR based survey? So actually, for execution of the survey, what you need is the ground survey. But the ground survey is very time consuming, isn't it? Anybody can tell, anybody has done the is a part of ground survey. How, if you use the total station survey, how long does it take? Either in plain terrain or in hilly terrain. How much time it takes to carry out the survey?
In case of total station, is very easy and time saving.
Yeah, yes. Now there is more document. Total station saves time comparative to
Other yes,
theodolite,
yeah,
vertical theodolite.
exactly, yes, yes.
Isn't it?
But in
So why it
yeah,
saves? Actually, total station is nothing but it's a digital theodolite. The recordings are automatically recorded. Anything you means
yes,
you just
yes,
means before total station we used to manually note the survey
yeah,
results.
yeah.
Now that is eliminated by
Theodolite.
total station. It is electronic theodolite, you can call
Yeah,
it.
mostly nowadays we are using the total station.
Yes. So you are using the total station. No, but total station also, because total station for 1 kilometer survey, depending upon the environment and site condition or type of weather topography, you do maximum 1 or 2 kilometer per day.
Yeah. Mostly we using building structure.
Isn't it?
100 meter to 200 meter.
Yes,
per
in
day.
hilly terrain.
That is
Yes,
Yeah.
mostly in hilly terrain, sir.
Yes, hilly terrain, it is because
Yeah. But in case of building structure,
correct.
small pocket, we like construct a hospital building like this. In that case, that we use this total station is very useful. It's time saving.
Correct. And then,
Yeah.
but the total station, because the total stations, as long as to whatever distance you can see, you can do the survey at one, because total station required the centering and placement, isn't it?
Exactly. You're right, sir.
And
Right,
shifting
sir.
of total station again, it need time. So depending upon the topography and then topographical features, if there are many buildings, then you can do with urban areas. It takes more time than the rural areas where visibility is not clear for long distance.
Yeah. Rural, in case of rural, it's not possible, sir.
Yes, in rural where there is a vegetation, number of trees.
Mostly in hilly area.
Yes, in hilly areas. And then
Yeah.
now total station, and then ultimately our basics of topographical survey is same. So here, when we are working on roads, it is a open system, open travel system. And
Yes.
then when you are on the field, you got to there are errors involved. So
Yes.
any survey method, it has to be closed travel survey.
Exactly. Yes.
Isn't it? So then you have to close it with the traverse. So in the open traverse, so then what you do is we do combination, total station along with DGPS.
DGP, exactly. DGP is the most useful one, but we have to learn in detail, sir, how to take out the readings.
Yes, yes. In this training session, because I am just mostly discussing the TOR and I am giving you exposure of that. In the further session, you will be going into learning into more details about it. But I give you the exposure because how the DGPS means why DGPS come into picture. You do total station, but total station because you keep on progressing from 1 kilometer, 2 kilometer, 2 kilometer, 4 kilometer. There are errors involved because it's humanly not possible to 100% accurate. So, and then topographical survey is done to a desired accuracy, and then terms of reference define to what accuracy do you need. For road purpose, we have 5 centimeter error in horizontal and 5 in the vertical. This is I just show open that document because to what accuracy, and then that accuracy anything if you do total station survey and then you have to close it. You normally if you don't have DGPS, what you do is you go you hold to part. You do 1 kilometer again come back 1 kilometer and then close the survey, and then whatever error is found that is distributed in number of stations where you have placed your total station. Hope everybody understand that, or should I explain in detail this also? So, and if the error is more than the desired accuracy, you have to redo the survey. You can see the accuracy is defined here in this law. To carry out the topical survey, one of the most crucial clause, this already we know it, which can meet the following accuracy level to be adopted. For land-based survey, fundamental horizontal accuracy of 5 centimeter or better, fundamental vertical accuracy of 5 centimeter or better, and more than 50 points shall be measured per square meter. And for aerial-based survey, now aerial-based is LIDAR or photogrammetry, fundamental horizontal accuracy of 5 centimeter or better, then accuracy is desired is same in both the cases. But the issue here is why you go for aerial or LIDAR survey? Because LIDAR survey at the present, it is prone to, it is a highly technical job, and then the accuracy available at the moment is not, you cannot get that kind of survey. So, what we do is we do a combination of the survey. So for initial feasibility study or working out number of alignment, and we go for LIDAR based survey because this is very quick survey. For total station, you see, you already so that sometimes it goes as low as 100 meter or 200 meter per day. But LIDAR based survey, you can do even 100 of kilometer. LIDAR based survey, there are anybody has exposure to LIDAR?
I have just knowledge about the leader, sir, but not I have done leader survey. Mostly leader
Okay,
survey
so
is
the LIDAR is basically yes, please.
a device which through laser to various objects when then scanning all the objects comes in front of this that device.
Correct.
And that generated in software, then it will comes in the form of 3D, and we can measure all the dimensions and all the levels on computer after
Yes,
downloading.
That's correct. That's it. Basically, LIDAR give a very better visualization, but for actual ground calculation quantity and working out the detailed levels, LIDAR is not that useful. But LIDAR will give you very good. I'll show you the LIDAR based drawing. I have it. I just open that also for you. Just 1 minute. You see, this is. So during initial part of ground survey, we use the LIDAR gives aerial picture. This is from the aerial LIDAR. LIDAR also can be, there are 2-3 types of method by using LIDAR. One is, this is the photo aerial based LIDAR, drone based LIDAR. Then for rehabilitation, we use vehicle mounted LIDAR. And then sometimes, even a person can carry it on himself, on his back. and then walk along and then do this survey. So
Yes,
depending
sir.
upon the, yes, please.
Most LiDAR device is fixed on a vehicle, then the vehicle is moving with a particular constant speed, and then the LiDAR scanning all the objects come in front of them.
Correct. So what LiDAR collects too many data. You know, it requires a lot of office effort. You know, filtering of the data. You know, LiDAR collects loud data. You know, it means per square meter there are number of points, and then through different softwares or technique you have to filter out.
Yes,
And then getting correct level from LiDAR is very difficult. Yes, please.
yes,
So
sir,
this
you are right.
is. So just for your reference, I just provided this is the means a for means for a greenfield project alignment is done, and then this and then later on once this means this is a LiDAR survey, and then you this is the ground survey. So from LiDAR you get qualitative information. And to work out the final alignment from where in greenfield alignment, there are many alternatives possible. So LiDAR within means for 200, 300, 500 kilometer within a month, you can establish the viability to approximation that okay to approximate which is the technical viability and economically also to some extent maybe so some 20-30% accuracy you can work out. And then based on alternative you decide on focus on one alignment, get it approved, and then actual then ground survey, total station survey at present it is a must. So once the LiDAR with the from the LiDAR survey presently we are using for working out the best alternative out of so many number of alignments. Because LiDAR does not give that. That is why the topographical survey it's only say provide the accuracy, and it says that you can use the number of methods, whether it is LiDAR based, total station, GPS. So normally for working out the best alternative, we use LiDAR survey, and then once the best alternative is established, then we do total station and DGPS survey. And now, because everything can be done by total station also, why DGPS? Because DGPS establish the control point faster. So that, you know, you don't have to redo the survey. More than 10 points shall be measured per square meter to establish accuracy of the chain point survey using DGPS for horizontal accuracy, and then for vertical accuracy, it shall be carried out to establish fundamental horizontal accuracy. So this clause of TPR defines that how many number of points are needed, and so this will function then through fairly accurate quantities. And then these are the deliverables, you know, raw DGPS data for entire highway length and adjoining areas of interest. Now, you know, when topographical survey you do it, what are the adjoining area of this way? Suppose you have to construct a highway, say 4-lane highway. You do survey topographical survey of 60 meter, but you know there are major bridges, there are big crossings. So once you cross a river, major river, so sometimes you know the bridge length goes as long as kilometers. So for that you have to the bridge level has to be fixed based on the hydrology of the river. So normally what corridor, you know, the TOR also define the corridor, how much corridor has to be surveyed. So normally for national highway, what is the width of corridor to be surveyed? Anybody? It will depend on ROW. You know,
minimum ROW, sir.
Yes, please.
60 meters ROW we are providing for NHA for any 4-laning program.
Yes.
corridor should be more than 60 meters, I think.
Yeah, no, it's more. Yeah, it means generally for straight length it is ROW, but we do because topographers will be because ultimately if there is a rehabilitation project you have to improve the alignment or if it is a greenfield because initially you don't know. Suppose it's a greenfield project,
Sir.
so you don't exactly know the alignment because what is alignment? Alignment is a combination of straight and horizontal curves.
Yes, sir.
So unless you know the radius of the curve, you don't know the exact alignment. On the map study, what you have done is you have done the broad-based alignment on the desktop study. So from the desktop, what we are doing is ultimately understanding the desktop. From desktop, we are whether it is it is easy for a existing road rehabilitation project, but for greenfield project. So we discuss both. We start with this
Yes,
first.
sir.
Let's yes, please.
For widening of the existing road already, there is the corridor will be, at least we have some idea how to do the survey.
Correct.
For an entirely new greenfield highway means then we have to explore the first alignment we need to explore, sir. Then
Correct. Means ultimately, suppose for a existing road project, you know the corridor, but you have to improve the alignment. Suppose a state highway or a rural road has to be converted to national highway.
yes, sir. Yes.
To bring it to national highway standard, you have to improve the alignment. You have to improve the curves. You have to sometimes bypasses to settlement areas. So initially what you do is you do survey entire corridor within the ROW, and then setting survey team again and again it will be very costly. So what we do is normally we do first the traverse survey
Sir.
because initially based on just on visiting the site you know that what is the sharp curve where you need improvement, where you need the bypasses. So here, the LIDAR survey help you, from LIDAR survey, you get the means photograph almost. It's like a video photograph of entire this. And then from that survey, you can fix the initial alignment at your office. And then from that alignment, you do normally where realignment is required, you do extra corridor survey more than ROW because you know that while establishing the final, you have to do some fine tuning. So
Yes, sir.
that way,
Yes, sir.
isn't it? So that way, what we do is we survey the corridor, and then for a specific purpose. So for major bridges, you have to survey the even river also for 300 meter. Even though your ROW for road is says 100 meter or 60 meter, but to understand the hydrology of the river, so you have to work out the cross section of the river section also. So for that, you need levels along the river across the highway for say 300 meter on each side. So 600 meter at major rivers, major crossings. So this is all this is all indicated in the terms of reference. It should be included in the terms of reference. Because I'm focusing on discussing with the terms of reference and then different type of methods and what the different methods, different type of surveys will provide you what kind of information, and then this kind of information, how useful it will be. You will be getting details in further presentations about the LIDAR, about the GPS, very micro details. So today we are discussing the terms of reference, and in the terms of reference means if LIDAR survey, because LIDAR survey on the existing road you can do it using the vehicle mounted LIDAR, but for greenfield you need a drone mounted based LIDAR. So but drone-based LIDAR for every greenfield project you can't do. You do for minor small project, a single bridge project. You may not go for LIDAR survey because there is a cost implication also, because LiDAR surveys are costly, but it gives you, so for large projects, say 200 kilometers, 500 kilometers, more than 100 kilometers LiDAR survey, and then for HAI or ministry project, for because for long length of roads, LiDAR survey provide economy in terms of time, because you can quickly get the information. Okay, any question on this?
Sir, your
Yes.
computer screen is not being shared, sir. It's not visible to me.
I'm sharing again. I will
Maybe
just
some
wait.
technical snags.
Okay, no, I'll zoom it, because presently I'm just I opened a PDF document. Can you read this now?
No, sir.
No.
No, sir.
Okay, I'll just reshare it. I'll just close the sharing and then do it again. Let's see. Just hold on, please.
Yes, sir. It is
Visible,
visible,
sir.
sir.
No,
Yes, sir.
no, this is a PPT presentation. I'll just show you whether this is also visible. You can see. I keep shifting. Whether this is also visible?
No, sir.
No, sir. Again, it's gone.
Oh shit, this is gone. Some problem. Just hold on, wait. This is visible?
Yes, sir. Now it is visible.
Okay, there is some issue. Maybe in the break I'll sort it out, because so you see, in such type, here we are doing an alternative alignment study. Just a simple. Just hold on. So you see, here this is in a hilly terrain, there is a tunnel alignment. There are two alignments. So this alternative alignment study here, Google or if working out for initial purpose, this helps. You can see for tunnel alignment, these are the two alternatives studied. So here, because ground survey is very difficult. So, the satellite and then or LiDAR survey is helpful in such kind of conditions. So this mobile terrestrial LiDAR method for widening and rehabilitation project, we use mobile terrestrial LiDAR method. Okay. Aerial LiDAR method for greenfield. But here you need permission because for drone, because now it has been simplified to a large extent. And but actual construction, you need LiDAR combined with total. For conventional instrument, the total station. Total station now it is a conventional method, we call it, can be used for bypasses, water bodies. But for a large project, which is a 100-kilometer project, will include number of bypasses. So initial feasibility, for establishing initial feasibility or viability, we use it LiDAR and as per current TOR of Ministry of Road Transport and Highways. And then we do conventional method, total station also. Then there are, along with total station, now total station also, total station is used for XYZ. We use combination total station along with leveling instrument. That is called digital level. Nowadays we use total station and digital level. And then DGPS used for, you can see DGPS auto level can use for checking. So DGPS is, we use it for establishing the control points. So normally say if we have to design a 100-kilometer of road, and if it is a greenfield alignment, from LIDAR survey, we work out 2-3 alignment, and then from 2-3, because you get some idea of profile, not to the extent it is 5 centimeter accuracy, but to get fairly idea of the topography and what could be the whether technical feasibility can be established. From LIDAR survey, from to establishing technically, then you go for DGPS and total station based equipment. So first from LIDAR survey, we do technical and financial or economical viability. Then for actual execution, once the feasibility is established, we have to go for ground survey. For now, during the ground survey, what you do is we use DGPS for establishing the control points, horizontal DGPS along with the auto leveling instrument, whether it is auto level or digital level, because horizontal control points are fixed by this global positioning system DGPS, and vertical fixed by using the auto levels. And then we construct pillars or establish benchmarks, horizontal control points, vertical paint points or benchmarks. So every 10 kilometer, 5 to 10 kilometer, we establish horizontal control points. So when we do the survey from one control point to another control points, we do the total distance survey, and then we check whether the error is within the accuracy, available accuracy. If it is within the accuracy, we distribute it, and then this topographical survey, and then the topographical detail collection is done. Similarly for vertical. So DGPS we used for closing the traverse. So with using means DGPS, we do quickly, the close to, otherwise, back and forth survey 100 kilometers, and then the survey, the principle of survey is whole to part. If you have to carry out 100-kilometer road survey, so 100 kilometers and going back 100 kilometers takes too much of time. DGPS, normally, the DGPS, you hold a GPS instrument for about 1 or 2 hours, and then you get from satellite a correct, and then you know what is GPS and DGPS difference? You also nowadays you have a mobile phone also have got GPS, and this also you can see that 6-meter accuracy details it can give you. So, and why you do DGPS and why not GPS only? Anybody?
DGPS has two instrument in the surface area, and that both the device connect with the satellites, number of satellites, and then these two devices are calibrated with the satellites. That's why the DGPS accuracy is more than the GPS.
Yes, no, but why DGPS? Why with single GPS also you can do the survey? Means why not GPS? My question is that.
GPS, we can go through survey on GPS also, but accuracy is not reliable.
Yes, and why not reliable? Means, and why DGPS is reliable?
Yeah, DGPS has a two device, and both the devices are calibration each other, and then these devices are calibration with also with the satellites also.
Yes. This is again same thing.
More accurate.
Correct. You're right. But basically, to some extent, means basically, you use GPS. GPS take there are many error. Environmental error, and then Earth is a spherical surface. So DGPS for short distance, because the Earth radius is very high, Earth circumference. So why DGPS? Because two GPS when you differentiate means between the two GPS, the distance is very less. So the spherical error is is negligible. So that is why DGPS is required. Otherwise, if you use only one single GPS, the curvature error due to curvature comes into the picture. With two differential GPS, the error due to curvature is eliminated.
Yes, sir.
Because the
But,
10 kilometer compared to 64,000 kilometer radius of the earth is means negligible. So
but,
relative position when
uh,
yes please.
in comparison with the total station, DGP is not much accurate than the total station, isn't it, sir?
No. DGPS is as accurate as even as it is more accurate actually. In DGPS is no problem. It is gives this because total station there are manual errors involved.
But I saw in somewhere, sir, that the DGPS has an accuracy of 150 mm accuracy level. In total
Yes,
station,
but
it is 4 mm, 4 to 5 mm accuracy.
no. But total station actually total stations in total stations how many shiftings are there? Ultimately suppose you do 1 kilometer. So you have to go to 1 kilometer again come back, or you do suppose 100 kilometers because accuracy depends on the extent of the survey,
Okay, sir.
isn't it? Because the principle of survey, basic principle is whole to part. So you have to do first whole survey and come back. If you go 100 kilometers back and then there are errors are likely to be only total station is accurate when the distance covered by a single point, single station of the total station. Closer the spacing of shifting of the total station, better is the error, better is the accuracy. Sorry.
Okay, but I think we are going to survey a tunnel survey for a whole hilly area. Then we are
Yes.
go for the closed towers, no? Then there are
Yes. No. Tunnel also actually. Yes. First thing is you have to means establish whether a tunnel is possible and whether it should not go because ultimately you are you plan to construct a tunnel from the hills and then hill level goes up and down and then that you are guided by tunnel slope because tunnel slope should not be more than 3%. So
Yes.
if both horizontal accuracy from DGPS you can fix for the both the ends of the tunnel.
Okay, sir.
Both the end means ultimately for planning of tunnel how you go. We've done it in the Himachal Pradesh.
Yes.
So that way what you have to do is first from GPS we establish the points and then both the ends of the tunnel and then between the both ends of the tunnel then the ground survey top of the tunnel is required. So all along the alignment then we do the what is the level. Based on that, we establish whether tunnel is possible or what could be the length of the tunnel. Because establishing the length of the tunnel, topographical accuracy to the DGPS and total stations, DGPS is very important. But for tunnel survey, you cannot entirely, you will do total station survey all along. You only do the leveling. Because you are not constructing road on the top of the road. You don't need the detailed topography. But whatever tunnel alignment you have planned, you want to do the level. I'll show you this drawing. I have this. You can see. This is the tunnel alignment. And you see these are the levels. So here along one alignment, along this alignment only we worked out the tunnel profile. This is the profile of the hill. And the tunnel is, now the length of the tunnel will be somewhere here. Here to here. Depending upon the height of the tunnel. Okay. So we have a break this or should I continue up to 11:30 and then we have a break?
सर ब्रेक कर लेंगे 11:15 पे सर 11:15 सर
ब्रेक करेंगे, ठीक है। So I just can you see now my screen or is still not visible now?
विजिबल सर
Visible, that's great. So here now we come into longitudinal cross section because if we are discussing the tunnel, the longitudinal section for the tunnel is important. So the topographical survey, you have to work out the longitudinal cross section. Then again, before that, you have to construct the pillars also. The width of the corridor will generally be given as under. Okay, this is just going to the TOR of this. The width of the survey chord should be taken into account the layout of the existing alignment, including the extent of embankment and cut. This is for rehabilitation, existing road. The cut slope on the general ground profile. While carrying out the field survey means total station survey. The widening scheme, left, right, should be taken into the consideration so that the topographical survey covers sufficient width beyond the center line of the proposed divided carriageway. Normally, the survey should extend minimum 30 meters beyond either side of the center line of the proposed divided carriageway or land boundary, whichever is more. This is a normal case of but if in case of a road crossing or railway crossing or river crossing, the corridor has to be increased. Because when you have a junction, a major junction, so major junction, you have to the improvement may go particularly in hilly areas, because the slopes are you have to consider the drainage aspects also. So in that case, you have to do, because normally we do 150 meter at for major junction and 50 meter for all the either side of the road center line. For normal national highway, expressway it goes more. Because in expressway there are or interchanges. If you go for on expressway design, there are interchanges, cloverleaf interchanges. Now cloverleaf interchange, the radius of the turning radius, cloverleaf interchange, cloverleaf or trumpet interchange. Have you heard of it? Or those who have come across any expressway, or you must have traveled on expressway, the radius is 90 meter radius or 120 meter radius of the turning radius required for right turn itself.
Yes, sir.
So here the area of survey required is more. And for major river beaches, for hydrology, you need 300 meter river survey. So the width of here, I think it must have been mentioned. I just go with that. Where you see where existing road cross the alignment, the survey will extend a minimum of 100 meter on either side of the road center line and will be sufficient width to allow improvements, including gate intersections, to be designed. For 8 grade, it talks about 100 per meter. For grade separated, it can go up to 300 meters. So while framing the terms of reference, you have to keep it in the mind that at all the river crossing, road crossing, extra width of is required to be surveyed. The surveyed alignment now, after carrying out the survey alignment to be transferred to the ground. How it will be transferred? So when you do the survey, you fix up the benchmark. Reference pillars and benchmark. Reference pillar, the size is given that okay, this has to be established, and then based on this, say it shows the site 15 by 45 centimeters shall cost in RCC, because this ultimately when the contractor goes to the site for construction, the alignment is transferred based on these control points, because alignment is available with you. You have drawn the alignment on your screen. You carry out the topographical survey, bring the topographical survey to total station survey, transfer it to your computer, draw the alignment, and then the alignment is to be transferred at ground for exactly working out at the site the land requirement or structure, what are the land to be acquired, structure to be acquired. When you go to different agencies, based on their requirement, you have to just provide them the information that how much land of as per IRC SP9 for rolling mountainous and steep terrain. Now, why closer interval? This is for accuracy in quantity estimation. No process, because wherever there is a change of topography, closer interval is required. In plain and rolling terrain, this is not that important, but on mountainous and steep terrain, a closer interval. Normally, for cross section, it is a cross section is 50-meter interval. The 50-meter interval cross section is okay for plain terrain, rolling terrain, but for hilly and steep terrain, we go for close to 10, even cross section every 10 meter to get the fairly accurate quantities. Because otherwise, quantities calculation likely to be inaccurate. It is written here that longitudinal section for cross section for length adequate for design and estimation purpose. So based on means while doing the survey, ultimately, it all more depends on the skill of the surveyor, survey engineer who goes to the site. This is established just for a broad-based purpose, the 50-meter, 100-meter interval. So cross section, it is because this TOR shows that it is 50-meter interval, but in case of a hilly terrain, we reduce it because it is already mentioned it is to be reduced at closer interval. You can see this law that cross section at every 50-meter interval in full extent of survey covering the number of spot levels of existing carriageway and adjacent ground for profile correction course and earth quantity calculation. Cross section shall be taken at closer interval at curves. The interval shall be modified as per IRC SP19 and IRC SP19 as it is indicated that what are the interval for rolling mountainous and steep terrains. For mountain and steep terrain, it goes to even 5-meter interval when very sharp curves are there. So now it is also that for feasibility study, cross section taken as 50-meter interval can be taken. So normally, because topographical survey, once topographic survey goes to the site, we do levels based on the required accuracy. But for feasibility, even calculation can be done for 50-meter interval. But for detailed calculation of quantity for execution, we do 10-meter interval. And then construction also develop as is mere. This is actually this TOR. This clause shows particularly for widening project rehabilitation. So georeference digital map office as project highway, earth surface, road layers, utilities, building, trees and features along data extracted and mapped on the layer marked on the map and tabulated data provided separately. I've shown you in my slide that all road surface, subsurface, inventory, payment is to be superimposed as layers using georeference data. So this is important because nowadays georeference means reference with global positioning system. You can just see it, the alignment, you can transfer it to the Google Maps. Anybody has heard of this WGS 2000? Because there are two different coordinate systems. So nowadays, what we do is that whatever survey is done, it is to be possible to transfer it to the geological reference, so that everybody can visualize it on the Google. Just like this is georeference alignment. I'll show in detail after the break, maybe. Hello,
Yes,
so we have a break for 15 minutes?
Yes, sir. Yes, sir.
Okay, fine. We'll come back. So any query on so far presentation? Now, actually, I want to just discuss with you the case study for a project so that it will be clear for you. Hello, all participants ready?
Yes, sir.
Yes, please. So now I'll share with you the case study for the expressive project, which I showed you the plus slide. Okay, before that, okay, I'll go to the LIDAR survey first. Okay, how the LIDAR survey is done. Okay, this is so we discussed the total station. I think everybody is aware. So this is the vehicle mounted LIDAR, and I'm sharing my screen with you. So I'm sharing you with the case study of an expressway project. You know, this is a project carried out in Gujarat. Okay. Though this is a project in Gujarat from Ahmedabad to Dholera. This is a presentation of the topographical survey. From the first is desktop. This is one of the desktop study, means all the process. We procured this, then drawn an alignment, carried out the detailed project, detailed ground survey. First is on the to alignment on Google Earth, then carried out ground survey with using the total station and GPS, transferred it, and then all the statutory clearances we got done. The project is under execution at the moment. So you can see, I'll zoom it. My screen is visible now. So these are the coordinates where the alignment is passing through it, and show you on the Google. The whole alignment is transferred. You can see this is a 110-kilometer road project. If you are aware of the Gujarat, there is a town called Bhavnagar. This is going towards the Bhavnagar from Ahmedabad. This is Ahmedabad. This is Ahmedabad Ring Road. And there is a greenfield town being developed called Dholera. This is a hub of this multi model hub as a part of logistic hub being developed here. So this is a greenfield expressway. You can see the alignment. Now we did the detailed design is now transferred here. So just to make you aware of it, you see this is an interchange. So normally, the project corridor is ROW is here. Now here, this is ROW. And then on one side, we kept a reserve for a railway because the railway track is also to be laid. Now you see the generally it is along the ROW about 100 meter is to be has been surveyed, but at the location of interchanges. Suppose here you see this is the trumpet interchange. So here survey corridor is extra. You see the direction of travel. So all this area has to be surveyed additionally. You can see the changes marked here. You see from here can you see it clearly? And then again you see normal ROW is here, but at the interchange location, here there is a crossing, another road is crossing. So then there is an interchange here. We called it dumbbell interchange. Can you see this dumbbell interchange? Is it clearly visible? Participants. This interchange, this is a cloverleaf interchange. You can see the survey corridor. Normal corridor is 100 meter only here. This is for rest area location, additional. Here the radius is also shown. But here, the radius of curve is, you can see it is 130 meter. So about 300 meter, 500 meter area to be surveyed on both sides of this this crossroad. This is fully access control interchange. Here, actually, this interchange is here because there is a new airport is coming up. Sorry. Hello? Can you see my screen? Participants?
Yes, sir.
So, can you tell us this? This interchange type? Because what are the ground extent to be surveyed here? Because normally, when you go, you keep in your mind only the ROW, the 60 meter, but the ROW is here only, the 60 or 100 meter. But here for interchange or any crossroad where elaborate interchange is required, too much of survey is required. This is I'm showing you just to make you understand that how much land survey is required in case of an interchange. And that is because this is this road is also a national or state highway standard because this is going to an airport here. A new airport is coming here. So cloverleaf interchange, you understand? I go to the, I'll open the this TURL session. Because what is the output of the topographical survey? What I meant to say here is now. I'm going again to the terms of reference of topographical survey. This time, this one. You see. Now, what is the output of the topographical survey? So, this is on the GIS system. So, this is the representation and accurate digitized projection of the survey on the topographical survey. Because as a part of this, now what you have to do is your DPR has to do is assist Kala. Kala, you know, is competent agency for land acquisition. So topographical survey details should cover all the details. This is a checklist. This is also estimate. Pidona. This is for a tunnel alignment. Okay. So here, how many alternatives you got? You see 1, 2, 3, 4, 5, 6. So from the map study, we worked out, we initially established so many number of alignment to connect these two endpoints. And then finally, this is finalized along with the discussion with the client. So here, tunnel length is less and this is the road length. Then along with this alignment, we did the final detail survey. So this is the profile already shown to you. There are two tunnels along this alignment. One is here and another is, sorry. Yeah. Is this one. Now, this is NHAI project tunnel study in J&K. So study, so to mean topographical survey should get the sufficient details so that this can be done. All these details can be worked out. The borehole location also to be provided by the topographical surveyor. You see, all these are plotted on this. And then tunnel cross section is worked out. You see, these are twin tunnels. Here, for road construction in the cut and cover, this is the ground level and the tunnel is constructed this way by cutting all this area. Some excavation drawing I'll show you. The tunnels are normally should be horseshoe. Can you wait in the second? Just for reference, I'm showing the civil drawing, then I'll just shift it to the expressway. Road drawings. The loops are designed. This is for in a hilly terrain in our industry tunnel. This is the profile of road. Another loop. Anybody from J&K in the participant? You can see what are this profile contains what are all the features profile should contain. This is as per IRC SP 99. Proposed level, existing ground level at center line, then ground level at 10 meter left side or right side, vertical alignment, schematic super elevation crossfall, and these changes. Particularly superstition is very critical very difficult to avoid in the hilly terrain because continuous curves are there. Transition curves sometimes it may not be possible to provide transition curves. So just like here, here at least you got some transition stage. Otherwise, you have to just cross it. Super elevation ultimately overlaps. So in that case, you have to judiciously design based on engineering judgment. See from road coming from here, then this is one tunnel, this is another tunnel, and then this 4-lane road. So I've got two case studies. One for on this hilly terrain in J&K and a plain terrain expressway project in Gujarat, plain and rolling terrain. Where in hilly terrain there is a tunnel, and then in the plain terrain we have a mainly complicated type of different type of interchanges. These are access control, fully access controlled. Fully access controlled. This is the road cross section. How much height is to be cut? The standard ranks has nothing to do with it. Okay, the standard I think is not relevant. So this is the complete set of drawings for the DPR drawing for the project. I will come back to the LIDAR survey and then go to the next. So how the LIDAR survey is done? So just for exposure, you will get detail in next presentations, other presentations.
Sir, I have a small doubt, sir.
Yes, please.
In the previous slide, it is shown that there are some points in the per square kilometer like that. There are some points, no, sir.
Correct.
Is it particular code or just based on the terrain we decide? By experience, we have to decide.
No, actually, for total station, there is a number of points are well defined. For ground survey, actual execution purpose. Because LIDAR survey, it collects thousands of data. You have to eliminate, you have to collect, filter and find out the relevant data. Because you see, this is the LIDAR equipment. So LIDAR equipment, it collects even the tree data, even there are building data. So there through software you have to eliminate that because what is relevant for the execution is the ground data. Isn't it?
My doubt is how many
So-
points we need to survey. That is it stipulated in any code or?
Yes. It is yes. Yes, I guess there in the TUR.
When we give
Just
work
open the
to
TPR.
some
It is there in the
senior
TUR.
consultant,
Yes.
Okay, we need to know how whether they have done any elaborate survey or not. So is there any code that so many points should be explored as per any code? Is there
No, no,
any?
actually, normally in the code, because the codes are getting, because the technology is faster than codes. Codes
Yes, sir.
will come after the, because right now we got this LIDAR technology to, but our codes, we have, you got ISP 16, and then you got IRC 7, because and in the terms of reference, these terms of ministry as terms of reference are 2019. It defines 50 points. I think we are just.
Yes, sir. That's what I want.
Yeah, I just you see.
Yeah. Very nice.
This is in the topographical survey. The accuracy has to be defined in the topographical survey. So this is for execution. So this is very clear here that for execution to
Area
carry
based
out
survey
topographical
50 points. Sir.
can be measured per square meter.
Sir.
Okay, but sometimes what is happen? One is the number of points, and another thing is the accuracy also. Because number of points, these points can be anything. So the points are not enough. Ultimately, these points should be relevant points.
Yes, sir. Yes, sir.
So along with the points, the accuracy is also defined here. The fundamental vertical accuracy, fundamental
Yes.
horizontal accuracy.
No. While giving the scope of the work or TOR to the DPR consultant, we need to just mention this clause and this code.
Yes. This
So
is
that
the
either
clause.
it should be more than this, but should not be less than this.
It should not be less than this. That is correct.
Than this. Okay. Thank you.
And yes, along with the point, you have to specify the accuracy also. That this one should be the relevant points.
Yes, sir. Sure, sir.
Because it is very well defined here. Okay.
Yes.
So because you get too many of points. You see now this is LIDAR. So LIDAR, it's about you see these are the points. These reds. It can. So this is the ground-based LIDAR. It just shows light and collect the points. Now you see at here there's a bridge here, so then it collects point of these piers also. Ultimately, what you are doing is a road widening project, suppose. So in road widening project, these points are not relevant. So all relevant time has to be filtered. Otherwise, LIDAR can be very inaccurate, the data from the LIDAR. So it has to be first, all the irrelevant points should be, LIDAR gets too many points per second. You are traveling at a constant speed on this thing, or otherwise, this is mobile, and then this is terrestrial LIDAR, you see. So on terrestrial LIDAR, just it takes pictures. So it shows a laser rays and collect the points. You see, these are the LIDAR cloud points. So from these relevant points only has to be collected. So mainly for road planning, what the purpose of the topographical survey, is this part of it. The purpose of DPR. It's all so survey and designs are required mainly to address the following point. Necessary. It should be safety and environment protection. So safety and environment protection means the environment protection means normally you have to ultimately from the topographical survey data you go to environment ministry for EIA clearance. Environment management plan and all these are prepared based on the survey data. So based on the details provided by the topographical survey. So means most important thing is the topographical survey. All these things are to be established on topographical survey. You see, for environment, this is one of the, for the expressway, you see, the CRZ, this coastal regulation zone. This particular road was going to this coastal area. So for getting clearance from CRZ, for the ministry, means environment ministry, or for clearance of coastal regulation zone, you have to get clearance, statutory clearances. For environmental clearances, what are the clearances required? Forest clearance, environmental clearance, and then number of trees you are going to cut, that is also. And then if your wildlife, if your road passes through any wildlife area, then you have to get clearance from them also. So, this particularly first for Kriyas. So we have to show everything on this map. This is along with this topographical survey also. This is on a map we have shown it. But what are the major biggest flaws? Because based on this, once first we do this map, we submit it to the relevant agency. Then they form up the TOR, do again topographical survey, carry out the survey, then provide them the details, and then you get the clearance. I think you are aware of it. Statutory clearance, what are the clearances required, and for land acquisition also, because you have to transfer it to the this surveyed point, means to all the topographical survey and the design alignment, land maps, revenue maps. So you got to digitize the revenue map. You have to collect revenue map and then digitize it. This is also shown in the TOR. So in case of mobile lidar also, it's established that what kind of a 360-degree panoramic images are required in addition to this. But in my view, the lidar survey is presently limited up to the feasibility study. Because lidar presently we are not able to get this kind of accuracy. This. But lidar is very fast. So what we do is we do combination of this. We do lidar survey and parallelly means we do, but ground survey, total distance survey can be done only in single alignment because lidar can survey fairly large area. You can see from this aerial lidar, very large area can be surveyed, and even for this also, it can collect data beyond the means you cannot, you can do a lot of large area can be surveyed from lidar. But ground survey, it takes very large time and resources for carrying out that amount, that kind of. So total distance survey is done limited to ROW or the construction area. We call it corridor of impact. So within the means to the area where construction means actual ground, because total station gives very accurate result, but this accuracy total distance is out of this lidar and this total distance give very better accuracy. Total station and auto level based survey. So presently, for feasibility study, lidar helps in the quick survey and getting the alternatives to be analyzed and with economic or establishing the viability of single alignment. Particularly in greenfield, the drone-based lidar are very helpful because sometimes you cannot go to that area, so you can find out exactly that to where the alignment should go, and then you carry out a ground survey for that, detailed survey, work out cross section quantity as per TOR. So the TOR is defined here, cross section and this thing also. Even you see the topographical should be, the scale should be 1:1000 scale. For adjoining areas of interest also, like river crossing, and then contour map of 50 centimeter, 0.5 meter interval. So this 0.5 meter interval is good enough normally to get fairly accurate quantities. Then again, you see the ultimately lidar always cannot fail. So wherever lidar, it is always lidar or better technology. So for construction accuracy, the total series is better at present. Then all building structure. These are all the data. This is very important because ultimately you have to pay to compensate for the land or building or utility service acquired. So collection and extraction of detail for all features such as structures, bridges, culverts, utilities, existing road, electric and telephone installation, both overhead as well as underground. huts, buildings, fencing, trees, because undergrounds cannot be calculated by topographical survey. We use other method like GPRS, or we get information from the respective department. But all the overground features can be collected using the topographical survey. Now, the width of corridor, the TOR should also define the width of corridor. So it is given here. The width of survey corridor is taken into account the layout of the existing alignment, including the extent of embankment and cut slope. This for existing rehabilitation project. That is right, left, symmetrical, and it should cover, you see, sufficient width beyond the center line of the proposed divided carriageway. Normally, the survey should extend a minimum of 30 meters beyond either side of the center line of the proposed carriageway or line boundary, whichever is more. So this 30-meter is now it is for a general national highway. But for expressway, because now expressway we go for a very large median, means 50, wide median, 15-20 meter median nowadays we are going. So there we go to this 120-meter survey, something we do double of 60-meter on either side. Here the corridor is 30-meter on either side, means 60-meter corridor. But in expressway, go for as large as 150-meter corridor. Now, this is bypasses. Now, in the case reconnaissance survey reveals the need for bypasses, the congested location, the traverse line would be run along the possible alignment in order to identify the selected most suitable alignment for the bypass. Because for bypasses, the alignment is not known. For existing roads, the alignment is known. So here, you have to first run the traverse line. First, the traverse line, then traverse line. After getting the traverse line, you have to establish curves of desired standard as per codal provision, and then again do the detailed survey done along with the curved alignment. Then the width of surveyed corridor will be widened appropriately where development or improvement of certain requirement or adjustment of the alignment, where just like where alignment improvement is required or alignment has to be shifted at some locations for certain obligatory points. Now, where existing road cross the line, now this is also the survey will extend up to 100 meter either side of the road center line. It is for junction design. For interchange design, I showed you in you see, normally it is 100 meter for 8 grade junction. But in case of interchange, it goes to as high as 500 meter. See, this is for interchange. This is a fully access controlled floor length interchange. So here it has gone to 500 meter. Then in TOR also said the reference pillar to be established and that should last till the construction. Means the contractor, because ultimately topographical survey is based on topographical survey. Alignment is prepared. This alignment is submitted to different authorities for statutory authorities for approval, and then for land acquisition purpose. Means the topographical survey has to be presented to many agencies, not only to the construction contractor, forest department, utility, water supply, or other, because depending upon their requirement, the topographical means the design alignment is to be presented to them. And then once the clearances is got, because the construction can be started only after getting the clearances. Otherwise, alignment may have to be shifted also. So the topographical survey should consider all this, even TO, and then this TO should should take care of all this. So sufficient area to be surveyed, so that future again you don't have to, because after sending the team again, once the survey is completed, design is done, and then again for some reason you have to change it, then it gets delayed. So TORs also now there's the clause for establishment of control points, and control points are to be placed in the terms of a pillar. So reference pillar of this required size. This size is established. 50, 30, 45 centimeter cast in RCB 15, and then how much it should be embedded so that it cannot be easily broken. So 2/3 is broken. You see, the size is 15 into 45. So, and then the reference pillar shall be embedded in the concrete up to depth of 30. So out of 45 centimeter depth, 30 centimeter is embedded and 50 centimeter is above ground. and which is should be painted yellow. So establishment mark of site, and then this GTS, the coordinate of this should be connected to GTS benchmark. This is the Survey of India benchmark, and it should be placed every 250 meter should be, and it should mention its level and BPM number, because this is most important things. Sometimes, you know, if the DPR, the construction goes after say 1 year or 2 year after the DPR is approved, then this if you don't have this benchmark at site, it is difficult to establish, to mark the central line. Again, you have to re-establish that, or you have to redo the survey. Now, boundary figure is just for the fixing the boundary, so that whatever is ROW acquired, wherever the proposed alignment follow the existing alignment, the boundary figure shall be fixed by the DPR concerned at interval 200 on either side the proposed right of way. So that this is the boundary to within this the highway will be constructed. Then this longitudinal, this is a part of DPR. This is not a topographical survey. Now utility and physical features. The topographical survey should show this also. To collect, because this is a part of topographical survey. The consultant shall collect details of all important physical features along the alignment. These features affect the project proposal and should normally include building structures, monuments, burial grounds, cremation grounds, places. This is called the topographical details. Railway lines, streams, rivers, canal, watermains, sewer, gas, oil pipes, crossing trees, plantation, utility services. So possible shifting of center line. So sometimes, you know, if there is a curve improvement is required, then some extra survey should be required. So because this is not known initially, so then it is mentioned in a vague manner that it should, the topographical survey should cover the adequate allowance for possible shifting of the center line at some intersection location. Because in urban area, it is likely to be located because of certain local issues that center line may have to be shifted. So the topographical survey, during the survey itself, it should collect additional detail both sides, because it is easier and less costly. That while doing the survey, you can collect additional information. So where there is a possibility of likely to be shifting of alignment, then you do some additional survey at such locations. Now, the subsurface utility, this subsurface utility is only if there are pillars available, then only you can, because normally topographical survey collect, if you suppose underground gas lines or water lines are there, if there are pillars are there, then that is collected by the topographical survey, and then further details or detail information about how the line is going, that can be obtained from respective departments. So this is what ultimately what is the output of the topographical survey. Now the information collected during reconnaissance and field survey shall be shown in a strip plan, so that the proposed improvement can be appreciated to the extent of land acquisition. Because with land acquisition schedule, utility removal of each type of assessed and suitable action can be in a separate strip plan for each of the services involved shall be prepared for submission of the concerned agency. This is important, because the different agencies require different type of information. So that is why now with the digital tool available, it is possible. We can just put it in the different layers, and then for different departments, other layers can be hidden, and the knowledge those layers which are required by that department, particular agency, can be presented to them for services are not required. It's only the land are required. And then from data, and then through GIS, because now ultimately everything is possible, can be put in a GIS map, this geographical information system. So the topographical survey, revenue maps, land owner, and then the data collected, other data collected. So secondary data collected, either means through hydrological department or through land ownership, those also can be put in the GIS drawings, in the topographical survey drawings, you can say. So everything is available in one on your desktop its location, and then required information can be readily obtained. So this helps in expediting the means in increasing the speed of the DPR, enhancing the speed of the DPR, and more accuracy, and checking the verification also. Because if you need to verify, you can simply just go, and if something goes wrong, initially you can find out who is the owner of that particular area. So topographical survey, the extent of topographical survey required is clear. Is it clear now?
Yes, sir. Yes, sir. Thank you, sir.
Okay, because now the presentation is likely to be completed faster, then we will keep about half an hour maybe for discussion, when you can share your experience. I was about to show you, this is an expressway. This is so now the general stage means ultimately topographical survey helps in. This is I think only 2 or 3 slides left. Yeah, last slide. So survey and design help mainly to address the following points: safety and environmental protection, cost optimization. You know why we are using this LIDAR, total station, auto level, digital level, so many number of instruments. So we can use judicious depending upon the type of project. So the TOR means this is the TOR I shown you, the issued by ministry, is a typical TOR for a typical highway project. But depending on project specific or depending, because for a small bridge project you don't need to LIDAR. For a PMGS enough. GPS may not be needed for a 100 meter road. 200 you need to lead. You are a greenfield alignment, particularly LIDAR survey helps in doing the work fastly. Means the topographical survey, which could have taken almost 6 months, now it could be done within 15-20 days by LIDAR survey. And then once one alignment is established, you take another 2-3 months, 2 months, 3 months for accurate survey. And then so ultimately the statutory clearance should start, because whole the process of execution. Why nowadays we will be able to, we could construct the road very fast. Now our minister, we already know 28 kilometer or 30 kilometer per day road is constructed, because we have through digital tools or through technology or DPR process, through using this modern equipment, we have reduced the time for preparation of DPR and tender document. So the process which could have taken before this technology or available, it used to take about 1.5 years or 2 years, sometimes 4-5 years for completion of a DPR. Now this DPR can be completed into 3 or 4 months. And any changes are required, and then these are comparatively more accurate. But the accuracy depends on the how properly this is done. Because the technology, if it is not used properly, then it can give you absurd results. I've shown you that, you see what is the data. This is the data collected by LIDAR. So many number of points. What we need is only 50 points. It gives you 500 points per square meter. But these points are irrelevant points or useless points, which should be filtered out. So LIDAR survey, actually the field survey takes less time, but filtering and then this requires a very fine expertise. A person experienced in the field, who has experience in filtering and then separating the data, cloud data, and then many softwares are more required for this. So LIDAR survey is costly, but it reduces the time. So for large length of the project, it is useful. For shorter length, total station survey, GPS survey is good enough. So I am done with this. And maybe you have any, we can discuss the rest of the time. We can keep it for the discussion or any interaction. If you have Any question, any queries, and if anybody wants to share your experiences on the topographical survey, then we can discuss it. Because I will also share my experiences. I'm graduated from because I got about 30 years experience. So I've done the theodolite survey, and now we are dealing with the. I'm a designer actually, highway designer. So we have dealt all kinds of surveys. So we have designed road using plain table survey, which is not used at all nowadays. So yeah, please, we can discuss any queries, points.
Sir, can you please explain how to do the LIDAR survey, whether it is aerial or whether through the any vehicle in deep forest areas, sir? Forest areas.
Yes. No, actually, you have a separate presentation for it, whole new full lecture for it.
Okay, sir.
So as a part of your training program, this is a 1 week training program. You have a full lecture. So I just done it. You see, this is in forest area on a green field, you do this way. So the lidar will capture only the means ultimately the green forest where too much of trees or forest is there, thick forest. So thick forest, based on color separation techniques. Ultimately, there are softwares, digital imaging software, which uses the filtering techniques.
Okay, sir.
I got here a slide for building area. I don't have the forest area. Maybe I could next provide. So here, you have to filter those irrelevant data. So
Okay, sir.
from here, it collects all the data. Then the irrelevant data, which is thick vegetation, because it collects level from all kinds of this. But the advantage of this is it can be done in the night also.
को बेड बनवाया तेने बेड बनाया शायद ये खाली ना
सिपाही के पास
सिपाही बनवाया
50 trial.
So, and then lidar survey, because total distance survey can be done only in daytime. The time saving is there in lidar survey. In forest, otherwise the lidar survey gives very absurd result if you don't properly filter it or if you don't know the knowledge. But in the other presentation, you will get all those details. That will be a detailed presentation. It's there in your program.
Okay, sir. Thank you, sir.
Yeah. Any other? Any other queries on this? Because mainly we are discussing here the TOR provisions. Yes, please.
चलो हो गया मेरे से हो गया ये आपका तो नहीं हुआ मेरा ही चलेगा
Yes, please. Anybody has any queries or want to share experiences, even any other kind of survey also, if you have done any topographic survey, any DPR, if you face any difficulties, we can interact, I can share my experience. Because every specific project gives some kind of challenge. Because this is just a broad-based presentation, but otherwise, you come across many things, culverts, even in topographical surveys, if the quantities can go anywhere if proper data is not collected. The experience of the person at the field is most important, very important. In case of ground survey, and the person who is processing the data, his ground his civil engineering background is very important. What exactly getting the proper data, extracting the data from the lidar cloud points, because lidar gives cloud points. Though it is faster, but then extracting data office In office, accurate data is very, very important. Any other query or clarifications? You see that your whatever data, if you get it, then even the data is there. The DGPS can be used to check the accuracy. Sometimes if you get any doubt or so, if there are no more queries or no more discussion is needed, then I request Neeraj. Close the session. I just. Anyone want to share their experiences on topographical survey or any challenges faced? Because I found many people from NHI, DCL, and they are working in the difficult terrains, difficult conditions. So I invite you if anybody wants to share their experience or any challenges faced during the DPR preparation or topographical survey and how they solved it. If you have any interest, then I can explain this recently carried out DPR. Because this is 110-kilometer alignment. And this is presently under execution. The greenfield alignment, expressway alignment, no at-grade intersection. At 1 ROB. Interchange, Dumbbell interchange. You see, this is a trumpet interchange. Hope people are aware of it. If you have any queries, I can further explain. And I'll say one interchanges in this 110-kilometer alignment. This is a open toll system. There is a toll plaza also, ramp plaza and two main toll plaza. Just see, all details are also provided here. The whole alignment is transferred in the GIS. This is the towns, and then alignment is going close to it, crossing the railway line. Again, the railway line. Major bridge here is the. So to reduce the cost, normally the bridge alignment should be perpendicular to the possible, if to the extent possible. lower lip interchange. This is just a diamond interchange for it. This is called as dumbbell interchange because of its shape, dumbbell shape. So here land acquisition is less than floor leaf. Because the slightly more than the required ROW. So this saves the land acquisition cost, this kind of interchange. But are less efficient also. This is 110 gram. Let me check if this mirage is there. So
because उसमें लिखा भी नहीं है ना वो खाली ये लिखा के क्षतिग्रस्त का ही है क्षतिग्रस्त भी नहीं लिखा है तो खाली कार्यालय में जमा किया गया लिखा है इसमें प्रमाण पत्र होता ही नहीं है
yes, please. Presenting the slide. If you have any query on these issues. Any further queries? Because I think I'm through with my presentation.
So any question?
Please feel free.
If the participants have any doubt or any questions, please questions or clear your doubts. It is once again requested, if the participants have any type of doubt on the subject, please clear your doubts. Sir, I think that there is no questions from the participants side. So I think that we may conclude today's session right now. Thank you very much, sir, for sharing your presentation as well as your experience with the participants. And I expect that your experience and your presentation will be useful for all the participants during their project activity. So thank you.
Thank
very
you.
much.
Thank you, IG, for providing me opportunity, and thank you, participants, for patient listening.
Okay, so thank you. Neeraj ji, now please finish the meeting.
Yes, sir.
अच्छा तो फिर एक सेकंड रुकिए एक मिनट ये पहले आपने तो बोल
Sure.
दिया तो लास्ट में डबल करके